Yes, we can hear you.
Yeah, thank you. Thank you. We'll start it. Others might join or they can go with the recordings, not an issue. So yesterday we were talking about this. So we were in the constants thing. We did discuss about constants. We'll continue from there. I'm sharing my screen. Okay. So now from there, so we had discussed about this event sequence types, and then also we discussed about mapping types and non-type. So we had discussed all the examples even, and then so this is another small important topic which we need to learn in Python. So let's just start from here. So that the topic is memory reuse in Python. You got it right. So or how this there is another thing which we need to understand, which is called immutable types. Right. So there is something. This is very basic thing, and it is good to know understand this. So there is something Python optimizes memory by reusing immutable objects instead of creating new ones. So why immutable objects and what is the advantage with immutable objects and how this memory reuse happens in Python? Actually, this is a very useful and very interesting topic, right? But try to understand this. Immutable means something which we cannot modify. And all these basic primitive data types like int, float, string, tuple, bool, all these are immutable, means we cannot modify them. So what is meant by immutable? Simply and in a simple terms, to understand immutable in just easy language, it is nothing but we cannot change them. You can see here, since these can't be changed once created. Once we create any object, if we cannot change it, such objects are called immutable objects. And such objects are reused efficiently. And to make you understand this scenario, what I'll do is I'll take one useful example. Right. So let me just take one example. So I'm using PyCharm, I mean this Python prompt for that. So I'm just saying clearing the screen. You know, right, how to use Python prompt. Let's see, let's clear the screen. So now you take A equal to 10 and then B equal to 10. Okay, print A, print B. You understand this? So now again, if you ask me, what is the topic we are discussing? This is very important, friends. From a development perspective, this immutable objects, reusing memory, and then understanding that at memory level, all this is going to help you a lot. Okay. As a developer, if you have this kind of understanding, then you can better design your applications. You got it right? So that is the idea. Next one. So now let me just take an example here. How this immutability is. Now I printed two variables, right? A10, B10 and printed A and B. I have a simple question for all of you. What is that question? What would be the address of A and address of B? Do you have two different addresses or is the address same? Or I'll just reframe, or address is same? That is the question. Do you have separate address for A, separate address for B? That is the question. So would you like to answer in the chat box?
I think hash code must be same.
Okay, yeah. Let's just check that. So if you don't know that, we don't need to worry about it. What we can do, we can just apply ID function. Just if you don't know address, just apply ID of A, ID of B. Now see that if you observe that the ID of A and B are same. Yes or no? Both are same. The addresses are same. Then you might we should introspect this. We should just go and deep dive into this. Why addresses are same? Because integer is immutable. All these basic primitives, that's what I just want to make you understand. The int, float, string, tuple, bool, all these are immutable. But immutable in sense to what level? So not all integer values are immutable, not all float values are immutable. Of course, all strings are immutable, tuples are immutable, that is fine. And we have bool just two values, they are immutable, that is fine. But here you should understand that this is very important. What till what range these integers are immutable means you cannot modify them, means till -5 to 256. After 256, if I assign anything, again that each value has a different address. Until that range, these values are immutable range and those values are reused. Suppose if I declare same -5 for 10 times, just only one copy is created. That one copy is shared by multiple addresses. I will explain that in detail. I will make you a clear this thing of that scenario. But before that, try to understand this basic thing. What is there to understand? It's very simple. Just only thing, couple of terminologies. Now we are trying to understand. I am again repeating it so that I can just easily put this into your mind. Immutable means something which we cannot modify. And these are all immutable data types: int, float, string, tuple, and bool in Python. Especially when we talk about int and float to set a, sorry, int, not float. I think mostly float doesn't fall into that immutable category, especially integers. From -5 to 256 are immutable types. For example, if you see this, you can see that I try to declare A and B and the addresses are same. Here just only one copy of 10 object, the object 10 is created and it is reused. And how is this working in memory? Let me just explain that in a paint diagram. Okay, let me open paint. This is very important, friends, especially understanding the design of language comes from here, that language design thing. Suppose I declare a variable A for first time. Then what happens? For this memory is created, an object is created, right? And then this 10 is put into that object. Okay, and this has some address. So assume that it is some 100 or 1000. Okay, let me put it as 1, 2, 3, 4, 5. And this has that variable name, that is okay, it's fine. This is the variable name. Okay. Now I declare again B equal to 10. This time our expectation is what? What is our expectation? One more object is created, right? And then that 10 is kept into this or new object. And B will, and this has some other address, 1, 2, 3, okay, 7, 8 something. And now B is pointing to this address. Assume that we have, this is what we think. Okay, we expect a new object for B2 and an object for A also. You can see this. Okay, but when it is immutable, we don't have, when two objects are same, don't look at variables here. Look at the values. In case of immutable objects or immutable values, first one copy is created. Second time you try to declare again 10, then your interpreter doesn't create one more new copy. It doesn't create this copy. What it does, let me just show you. This time, simply what your interpreter does is, our expectation is this. We might think two objects are there in memory, so that those two must have two different addresses. That happens for immutable objects, not for mutable objects. Mutable objects are efficiently reused. What is that? Mutable objects are efficiently reused. Just to understand this, I am just trying to erase this now. What happens now? What your interpreter will do? This is an integer. and it checks what is the range of that integer. Is that 10 falls into this range? -5 to 256? Answer is yes. Then what happens now? Then it is in immutable range. Any integer between -5 to 256 are immutable objects. Okay. So now what your interpreter does, it doesn't create another new object for this, which one for B. Suppose I am declaring here again. I'm adding B here. This is a beautiful topic, friends. Or you can take C equal to 10 or D equal to 10. Just take as many as you want. Now what happens? We know that integers are immutable from -5 to 256. Now your interpreter doesn't create a new object for B, but what it does is now this is B, right? And this is C and this is D. Now what your interpreter does is it simply as now assigns the address of this already created object 10. 1, 2, 3, 4, 5. Now what it will do, it will simply copy 1, 2, 3, 4, 5 to B, that address to just assign this address to B again. Okay. Now B is also pointing to the same which object? Same 10. This one. Okay. Similarly, same thing happens. Your interpreter again copies, checks whether this object 10 exists in memory, is already created in memory. Yeah, we have created for A. We have that. We can see that. For the first time, 10 object is created. And that is there. Then your interpreter doesn't create one more copy because that value is in immutable range. So now what happens? We'll just assign that address to 1, 2, 3, 4, 5. And now C is also pointing to the same object. Again, for D, is this 10 there in memory? Yes. Then what happens? It doesn't create another new object. It simply what it does, it simply copies the existing address to this variable. That's all. Now D is also pointing to the same object, which is 10. Likewise, what is happening here? Here, variables are different if you observe, but the address is same. And the number of copies of this value is just 1 in memory. Now, what is this happening here? This one copy is reused by all variables here, right? And this is efficiently reusing memory. You are not wasting memory for creating 3 more additional copies. That just that one copy, whatever you created, you are efficiently managing it. Got it right? So that is what this immutability, that is how immutability works, friends. The advantage of immutability is what is that? One copy can be shared by multiple references. Here, each variable can be called as one reference. Now you can see the advantage is we are avoiding declaring of additional 3 copies. So I hope you got a clear idea about what is that, what is immutability. What happens if some, and the same scenario is applied for any concept, any data type. It's not just for integers, even for strings, even for tuple, even for anything. This concept is applied. And to cross check that, always check the address. And when you see the address same for 2 different references or variables, and then you have to keep in mind immutability is in place. Right? And you have just only one copy created for such objects, and they are efficiently reused. Same address is assigned to B and C and D and anything. So this is the concept of what is that, friends? This is the concept of immutability, right? And how objects are created in memory and how objects are reused in memory. Is this clear? I hope I didn't confuse you. Yes or no, friends? Somebody is asking. Yeah, I think I'm sharing all this recordings in the, I mean, in our group, and everything is there in YouTube channel. I'll definitely share. Okay.
Sir, I have a question.
Yes, please.
Yeah, actually in Java, you see, creating object is two ways. Either you can mention a string s is equal to some sham like that. Otherwise, if you want to create object for as a class, test t is equal to new test.
Actually, there
So
are, if
that's
you talk,
how
yes, sir. If you talk
that's
about Java, creating it as a literal, that is one scenario. Creating it as object, that is another scenario. You got it
so
right.
same concepts is applicable for Python as well. Like test t is equal to new test for object creation. Same thing applicable in Python as well, or it's not required.
That's not required because for Java, the design is a bit different. You got it
Hmm.
right. Suppose
Yeah.
you declare a variable like this, Java uses string constant pool. Especially this immutability in Java is applied for what is that strings, right?
Yeah.
And if you talk about, if you declare a string as literal, then in such cases, all that string constants are stored in string constant pool. They are not stored in heap. You got it right.
Yeah. Yeah.
Only when you create it as object, those objects are created in heap. You understand?
Yes, sir.
And they uses the concept of interning. You remember that, right? So even here also, this is an interning. Which one? Whatever we are doing here is a kind of interning. Means reusing that is nothing but this scenario is interning. Understood, Sham?
Yes, sir.
But whatever you ask, almost the concept or that design is same even in Python. But the difference is in Java only some specific, only that class types are objects in Java. There are primitive types, right? Int, float, double, all that. They are primitives in Java. They are not actually objects. But here
This
in Python,
memory
yeah,
storings and executions concept will same Java and Python, right?
almost it should be. You got it right. Almost it's
Yes.
near. But only difference is Python is a bit pure object oriented. It's 100% pure, we can say, because if you see, everything is an object in Python, but
We
not in
don't
Java.
need to mention any type, specific type.
Correct,
By default,
but
it
not.
will take.
Yeah, yeah. Suppose if I want to make an integer object in Python, in Java, you have to use that wrapper classes. Yes or no?
Yes, sir.
But in Python, you don't need that. You got it right.
Hmm.
Because by default, everything is an object. You get that? That is the design difference between Java and Python. Other than that, this immutability, all that has a kind of almost similar. You got it?
Yes, sir.
Okay. So I hope I answered your question.
Thank you, sir.
Okay. So this is the idea. Yeah, I'll share all the recordings, friends. And do you get this immutability now? Right? I am trying to make you understand. What is immutability? This is, we are talking about the memory reuse in Python. A.k.a. means via, what is that? Interpreted object reuse, or this is interning. I just mentioned interning. Interning is nothing but you see whether there is already a copy with that value in memory, then you reuse it. I'm just making it very simple. I'm not trying to complex or mess it up, right? So what is that? You just see that that is already there, then just reuse it. Don't create a new one. That is the simple principle of this immutability. And you can see that Python, not just Python, this immutability is there even in Java or most of these advanced languages, even in C Sharp, all that. But okay, let's stick to the Python. Python optimizes memory by reusing immutable objects instead of creating new ones every time. And now you should be very clear with that scenario. I'm trying to spend some time here again and again. I'm repeating only just to make you understand it clearly. Okay, don't think that, okay, I'm just testing your patience. My only goal is to make you clear on this. That's all. Next, after that, these are all immutable types, especially when we talk about integer. All these values from -5 to 256 are in immutable range. Now, if you see here, you just tested for A for 10, right? Suppose I say C equal 10 d equal to 10. Yeah, I'll come back. We will discuss just a minute. Okay, let me just show you for C. Still it uses same address. Let me show you for D. Still it shows same address. You got it right, friends? So this is good, right? And if I ask a question why it is same, then you can tell that this answer. These values are in immutable range from -5 to 256. All integers are immutable. So in such case, if you have just one copy of that value, same is reused by all variables. That is what applied here. And in this scenario, what is used? A concept of interning is used. Is that clear? That interning means copying the same copy to all different variables is nothing but interning. Advantage, with one copy, we are managing all the references so that you don't need to create extra copy of variables. So we are managing memory efficiently. So this is the idea. Okay, friends. Yeah, somebody is asking question. Yes, please. You know you can ask your question. Hello. So somebody is asking question.
Yeah, might be, I think. Who, I don't know.
Okay, that's fine. No problem. Now you see, friends, suppose I just move out of range of this -5 and 256. See here. Suppose I say some x equal to 257 and then y equal to 257, then id of x. Okay, see that. And id of y. See this. Now you see, is this addresses same or different? You can answer in the chat box if you like to answer, friends. Are the addresses same or different here? Addresses, you can see that once I just cross that range, right, 257, then you can see that addresses are different, right? For AX, it is some ending with 240 and for Y, it is ending with 144. You got it now? So that is the idea, friends. Understood? So this shows that these are not immutable now. Are these immutable? No, these are not immutable. Because that interning is not applied here, and for each variable or for each value a separate object is created. Now the question to you, I know we are going very slow here, but the question to you, why for this 257 we have two different objects? Why not it for 10? That value 10, why don't we have different objects created? What is the answer for this, friends? Because
The,
very
the
simple,
range
right?
the range is -5 to 256.
Correct, exactly.
It crossed. That's why it's showing
Yes.
different rate.
If your values are within this range, then they are acting immutable. If your value is not within this range, then they are mutable. Means a new object is created every time. I hope I made this concept clear for all of you. Okay. So this means what? What is that? Python automatically caches. So the exact term, I mean pronunciation is caches integers in the range of -5 to 256. Caches means just whatever we discussed, right? So it reuses these values in this range, and all integers between -5 and 256 are reused same memory with the same memory address. Outside that range, I just made it very clear for you. You can see here a new object is created each time, and we have an example for both, which is within range of that -5 and 256, and the other one which is outside of -5 to 256. And we are testing IDs here. This example gives you a clear picture. Already I tested all this. Okay, within that range and outside that range. And we have seen outside that range of integers, we have different addresses creating, even though the value is same. Right? So this is the idea of what is this, friends. Immutability, using this memory. Okay, and interning all that. Okay, I'm moving to the next topic. And explanation with this, what within cached range, same object reused. This by now you should be very clear. And 300 outside that range, outside cache means this becomes mutable, new memory allocation each time. So this is what happens, and you should be very clear with this scenario, right? So that is the idea, friends. And now it helps you to understand even what is that for certification exams or anything. You can easily try to answer those questions which coming with all this immutability, interning, reusing memory, all that stuff. Okay, next one. Next topic is strings. What is that? Interning for efficient. Again, strings are also immutable. Right? Suppose you can see here. Python interns certain strings automatically, especially short strings. Again, you should understand which strings are interned or which strings are immutable. Sorry, which strings are immutable or which are not. So I just made it very clear for you which falls into that immutable category, which don't fall into that immutable category. Okay, short strings. See, Python interns are reuses certain strings automatically. What strings are these? Especially short strings. And second statement. See this carefully, friends. Strings containing only digits, only letters, digits, and underscores. Strings that appear multiple times in the same program. Such kind of strings are interned, or they are reused, or they are immutable. Okay. Now we have two scenarios here. So we have hello here and then hello world here. Let us try to test this now. Right. Let us try to create separate this thing here. So some string s1 equal to hello. Okay, I'm taking string 1. S2 equal to hello. Even strings are also immutable. Now you can just say ID of S1. In this scenario, the address will be same for both strings or not, friends? Definitely, it should be same. See here. Suppose you take another string. What is that? Hello world. Okay. Sorry, I think I missed some. Remove this bracket. Okay. Now ID of S3. This time it has a different address, even though we have hello in this hello world. Why? Because we have a space after that and a different word after that. Suppose I take another one. Let's take S4 equal to hello world. Again, I am taking another same string, repeating same string, hello world. Okay. And then ID of S4. Let's see this now. This will establish that interning this thing here. And you see this time for S4, even though hello world is same in both cases, you can clearly see that difference. Right? The addresses are different for both, even though the object is same. Why? Because there is a space between them that is actually totally changing that immutability scenario. You got it right. So here that's why we have a clear addition of these instructions when it becomes immutable. You got it right. Especially short strings containing only letters, digits, and underscores. You got it right. Such strings becomes immutable strings. Strings that appear multiple times in the same program. Especially now we have seen that scenarios. Now with this example, you should get a clear idea. Not you should understand one thing. Not every string is immutable. And to prove that, just check the addresses. If addresses are been same, then they are in immutable thing. If they are created as different, you can see for S3 and S4, hello world, we can see that there are different addresses. Means definitely this says that they are not immutable. They are immutable. They are acting mutable. You got it right. So this is the overall idea of what is that, friends. Overall idea of immutability and reusing memory. Okay. And the concept of interning and how do we efficiently manage memory. You got it right, friends. If you have any doubt, an iota of doubt, just ask me. I can help you to explain one more time. Okay. Don't hesitate. Only thing, understanding the concept is very important. Understood now? So next step. And force interning. Suppose a string is a value, not just string, and anything is not a immutable object. Then what you can do, you can apply interning by forcing interning on that. How do you do that? There is a method inside this system module, sys module. You can see that. By applying that intern, you can just make it as a, what is that, friends? You can force interning there. For example, let us test it again here. Suppose you have S3, right? Sorry, S3. Hello world is there. Now what I want to do, S4 equal to first import sys here. If you want to apply that intern method, import sys. When something is built in, you should always import that module, saying import sys. Now what do you do? Some S4 equal to sys dot intern of, what I'll do, I'll just try to add same string. What is in single quotes or double quotes? It's okay. That code doesn't matter here. So hello world, enter. Now print S4. The value is same. Just try to get idea of S3. Okay. And try to get idea of S4. And now you see that this time after I apply this, after I force it internally, then the address again is same here. This proves what? We have just one copy of hello world and it is reused efficiently. So we don't have two copies this time. And we are doing this, right? By using what? By applying this intern on a string. Right? Same thing you can test for even for integers and say, suppose we have something a equal to some 300. Okay, I just try this now. B equal to sys dot intern of a, enter. So this is, seems like this is not applicable for integers. See here. What is that it is saying? Intern argument must be string, not int. That clearly proves that this intern scenario is applied. This method is applied on strings, not on integers. Is that clear, friends? See, actually, these are all very deeper and very useful scenarios, especially when you work in some kind of development. That's why I bought all this, because I know that important. So I brought it, especially to get a deeper this thing of programming. These concepts are very helpful, friends. Understood now? So finally, I believe I made this topic clear for you. The concept of immutability, the concept of interning, the concept of what is that? Memory management, how memory is reused. So I hope you are all clear with this. Next, getting back to the floats. What is that? Generally, floats doesn't have this immutability scenario. Python does not cache this float objects by default. Each time you create a float, a new memory address is allocated. Okay, you can see that. For example, if you want to test on floats, this immutability scenario is not applied on float. Are you following, friends? On whom this is not applied? Immutability is not applied on float. You can take an example of f1 equal to some 10.5. Okay. And f2 equal to again 10.5. You have to use the same value, not variable. Print f1, print f2. And then check ID of f1. Okay. ID of f2. And now you can see that there. Right? What is happening? Is it same address or different address? Definitely it's a different address. F1 has different address and F2 has different address. Both are not same. Because this immutability is not applied for float. And that's what clearly documented here. Python does not cache float objects by default. Right? Each time you create a float, a new memory address is created. And this is applied for integers and strings as of now, what we have upside. Okay. Later, we can also see that this immutability is applied for tuples, and also there is a frozen set, I believe. Even for that, this immutability is applied. We'll check it there. Always I go with more of proof-based discussion. Okay. So this proves that float is mutable. You got it right, friends. So, and if you have any doubt anytime, if it is mutable or immutable, just check the addresses, right? And you can take a scenario like this and just test it. That gives you a clear idea. Understood now? So that's it, friends. Now let's go to the next topic again. 1 minute. I doubt if I am recording. Yeah, because these are all very useful scenarios, friends. Okay, next one. After this, let's go to the next slide. Where are we? Yeah. So we are done with this probably. Forced interning is fine. And we did discuss about floors thing and then booleans. Anyhow, for boolean, we don't need to worry much. We have just only two booleans. What is that? True or false? And what is that? These are singleton objects. This boolean, again, this terminology is something which you are hearing. These are important, friends. Right? So maybe once you, after this session, if you go and explore any standard websites, best YouTube videos, then you can see this kind of things. And but not every video, because these are something a bit of advanced into this Python. You got it, right? So when we talk about Boolean, we have just two values, and these are singleton objects. As name says, singleton means just only one object is created. Like, like what shall we say? Sometimes in some Telugu terminologies or some Hindi terminologies, when you have only single thing, right, and you cannot create one more, such objects you call it as singleton objects, meaning the same instance is reused everywhere. Yeah, of course you can reuse that address, but only one copy is created for that. And such objects you call it as singleton objects. Best example is this, whatever we have discussed. This is a singleton here in this scenario. Okay. So, but for fortunately for Boolean, you don't have a range. The range of Boolean is just true and false. Now you can see I took two true values and then tried to check the IDs. Definitely IDs are same here because they are singleton. As they are singleton, no new object is created there. Okay, so if you want to test it, what you can do, just take this example. Okay, is test equal to true, or you can just put it as is test1 true and is test2 equal to true. Right now you can just print it, right? Or you can directly apply ID is underscore test1, and then similarly you can see that test. Now in this case, if you observe, the addresses are same, and this proves that what is that? This is immutable and it is a singleton object where one copy is created. That's all, and it is reused by the references. Sorry. So this is overall idea of what is that? This beautiful topic of immutability and interning, force interning, and how memory is efficiently reused. So here you should understand it. Since the 4 copies, we are just reusing with one copy. We are just managing all that variables with just one copy. Are we efficiently managing memory or not? So that's all. It's like as simple as that. You go to a tea shop. Best example of this is right. You go to a restaurant and order for tea. For every customer, they don't create one new cup. They create some range of cups, and they just try to use that pool. That's all. Right. That is the best example there. So once you bought that, the same cup is served for many customers years together. Advantage, you don't need to invest more on cups and you are saving money there. Right? That is the best example. You got it right. Similarly, there are so many such things. You can just correlate with anything you know in your real life. Okay. Correlating helps you to understand concept better. And second thing, what is that? It also gives you a clear idea. Okay. Now, this is overall idea of what is that, friends. So this one. Now let's move to the next topic. Modes of coding. This already we know this, and I'll just want you just to get an idea. Generally, we have two modes of coding, interactive and script mode. Now, whatever I am doing here, so this is interactive, right? So this immutable thing is done, friends. Okay, so I'm moving to the next topic. I hope all of you are clear till this time. Before I jump to the next topic, can I get an S from you or no from you? Any questions till this? Any questions, friends? Okay, if you don't have questions, I should be good with that. Next after that. So now, modes of coding. What are different modes you use for programming? Two modes, interactive and script mode. Interactive is this, whatever I am using here. And this is not much recommended in real time because people don't use much of interactive mode, only for quick testing. Okay, or just if you want to check quick values or to do some learning, we use this interactive. For a real development, we don't prefer this because the disadvantage is this whatever I declare here, if I close and come back, I lose everything. And also, I cannot reuse these statements once I close this window. So automatically I lose everything and I have to recreate everything every time, which is a unnecessary burden on me. So that's why this interactive mode is not encouraged when you are working for real applications. So then what is that? Generally, we prefer script mode. I'll just show you how to do that. So this is about interactive. You type and execute commands line by line in the Python shell. That's what we call it as REPL, REPL. And REPL stands for read, evaluate, print, and loop. That's what it is. And whenever you see this word REPL, don't get confused. You already know that this prompt, whatever you are using, this approach, we call it as REPL, REPL. Okay, and what is the abbreviation of that here? REPL stands for read, eval, print, and loop. That's all. And where to use? Already I had discussed for quick testing, learning syntax, and debugging small code pieces. In these kind of cases, we apply this. What is that? Interactive mode. And how to open? I think this is the difficult thing for us, right? Opening command prompt and typing Python is the toughest part, right? I'm just kidding. Okay, what you have to do? Open command prompt and just type Python here. Just your Python prompt just opens like that. But before you do this, what is that you should do? You should make sure that your Python software is installed in your machine. Without that, don't expect this. Also, that class path is set. Your Python software is set to environment variables. Again, even if you install and if you don't set that Python software to environment variables, still you cannot see that here. The easiest thing is while installing itself, check that in the installation window itself, there is a add to class path checkbox. Just tick that. That will do the necessary this thing. Okay, so this is overall idea, friends. This is about interactive mode, but we do, and you are seeing it. I'm using it since the beginning of our session. This is the third session. From last two sessions, you can see I'm using it. But going forward, I slowly reduce the usage of interactive. I move more to the bash mode, script mode. Okay, so this is the idea. Next one, script mode. I'll just show you. This is what we follow in real time, right? So to create program as batches, what is that we do? We use ideals like PyCharm, okay, or we use VS Code, or we use this Jupyter, or we use this Spider. There are so many. Eclipse. There are so many. And how do you do here? You just write your code in a .py file. All your Python programs should have extension .py. And we execute the statements as a whole script. Right? That is the idea. Anyhow, we are doing that. Right? And we follow this. This is important in real time. Now I'm going to just test a small program here, right? In this window. You got it, right? So just a minute, friends. There are so many windows open. Let me close all those. Okay. Let me open. You can see this here. So what is that you need to do? You should create a project. Okay, close this, friends. You should create a project. Now to create project, you can go to the file and then just go say new project and provide some name. automatically project is created. And I have shown this in the beginning session. If you want, I can show you. I can help you again. We don't have a problem. Okay. So this is PyCharm. We'll use even Jupyter, all that. Okay. Whenever needed. So now I am using PyCharm. What you have to do? Just install this PyCharm in your machine, right? And if you need any help with these steps, let me I'll share document for all this. You don't need to worry about it. For installation also, I'll share your document. That makes your life easier. You got it right. So now I'll just create one more new for just showing you. You can see when I say go to the file and say new project, here you have to provide your project name. Ideally, I'm not changing this, but if you are working in real time, this changes. You don't put the same. Okay, you provide some meaningful name based on the type of project you are working. And then second thing, by default, it picks up the Python interpreter here. Before you install this PyCharm, you should make sure that Python software is installed. Just installing this is not going to help. You have to install Python software. Then once you come here, you can pick that interpreter. I have multiple versions in my machine, so it is trying to show me multiple interpreters. Right. So for me, whatever it is picking, that should be fine. Python 3.9 is fine, or Python 11 should be fine. Okay. 12 is fine, 13 fine, 14 fine. Right. Anything is fine. So it's up to you how to change it. Even I know how to change it after creating project. Okay. So I don't have a problem. And finally, just create it. And then a new window. I am just pushing to the new window so that it's easy for me to locate my thing there. I don't want to merge many things into one window just to avoid confusion for now. So it's trying to create virtual environment. Understanding this virtual environment is also very important for you. As a Python engineer, right? You work with different technologies, right? Python is not just connected with one, but it is actually having multi-connection. You work for it for automations, for data science, data engineering, big data, PySpark. There are so many things. Okay. So this is your Python project. This is how it is created. What do you do right now? You just right click and then what is that new? First, always create Python package. That is my suggestion. That is a standard practice. Of course, you can create a file directly here. Nothing, no harm comes with that. Right click and then new, and then just you can create Python file or a Python program. That is fine. It's okay. But the best practice is, what is the best practice? Creating a Python package is important. Okay, for now, I can just say that I put it as we are working on basics, I put my package name as basics. Okay. Now you can say I just created a package. I am not adding to Git there. So fine. Next. After that, so this you can see when I create it as a Python package, you can see that init file. When you open, nothing will be there. But it is a standard to have this init.py in a Python package. You don't need to worry much about it. This will be there. Okay. And we'll discuss more about these packages when we go to that modules topic in Python. Now, what do you have to do? I just create a file inside this Python package. Right click and then new and then Python file. And then just I'm just creating a script mode. So to understand script mode, I'm just creating a simple program, some test one. And that extension is automatically added. You don't need to add it. Got it? I just put test one and that extension is automatically added. So just add this. Now what happens? Just say some a equal to 10, b equal to 20, and then c equal to a plus b. Okay. And then just print it, print of c. Okay. So that's all. This is enough. This is a simple script program or bash mode program. We create bigger programs in the coming days. That's fine. But this is just simple example how to create a program as a script. And you can see all instructions are in one place and you are saving that program as .py. Sorry, friends. And finally, what you have to do, just you can see here, run button is here. And but it is picking up main here. You can see that. But which one I should run here? I have to run test1.py. Then the easiest thing is right click and then say run test. And you can see here, I got 30. So this is how you can create a bash program. Understood? So generally, this is what we use in industry. So that is a quick idea about two different modes, bash mode and interactive mode. So interactive and bash modes. Okay, I hope I made you clear with that, both different modes now. And you know which one you should choose if you are working really in development. And advantages, code can be saved, reused, shared, suitable for automation and projects. You can see here. Limitations, no immediate feedback, right? Errors, okay, that's fine. Errors are everywhere, not just only in bash mode. So this is the idea of this. Next after this. So finally, we are done with this modes of Python. Now we are moving to the next topic. What is that? Till this, do you have questions? And if you have questions, I'll just have a hard stop here. You can ask these questions. Any questions to you, friends?
So how we need to concat string and integer values in Python?
Okay, so that is actually, I can show you. But anyhow, we talk about string in detail, Sham.
Okay.
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 So definitely that scenario is covered there. Because we right now we didn't discuss anything about string except that basic data type.
Okay. Okay.
Okay. I can show you. That's not a big deal. Concatenating is, I'll just show you here quickly because you asked question. I just don't want you to disappoint. Okay. But that topic is already in this coverage. Okay. So
Okay.
now okay, it's a simple one. Okay, you have a string s1 equal to, suppose I put it as sham itself. Let me put it as a SHYAM, right? So now I try to concatenate. Suppose I assume your age is just 20. Okay, S1 plus 20. I get an error. I'm trying to combine S1 plus 20. Generally, concatenation, we do it with plus operator. With what operator? Plus. Plus is a concatenation operator. I'm trying to combine string with integer. It is saying clearly can only concatenate string to string. You got it right? So no integer. So it's saying, simply speaking, both should be of same type. Then you ask a question. What is that? Then can't I do this conversion? You can do that. Yesterday I had discussed conversion functions. Do you remember, Sham? Okay, what you have to do now here, come here, convert that string to that integer to string. Just apply a conversion. Now what you do, S1 plus, and you are applying a conversion on integer, that integer value is converted to numeric string. Then now you apply that. You can see sham 20. This is how you have to do the concatenation. This is how you
So
can convert.
if I need space in between sham and 20, then
If you need space, then what is that you have to add that space either here or you can add additional this thing. Okay, suppose you do one thing here. Okay, you put a space here. That is one scenario. One scenario. Okay, and then you try this. Suppose you want to do it in a different way. So then just
the time of
come
time.
here and take another string with only a space. Okay, and then S1 plus S2 plus and then str of some 20. You can just do this. Okay, sorry, that it is assigned there. I just put it like, and then you can see what is gone. Again, it's overridden. I got it. So what you do is again reset SAM. Now do this. You got it right. This is the other way.
Okay.
Understood, Sham? But you want
At the time
any
only printing time we need here, so then
sorry? If you want it only while printing, then what you have to do? You have to take both these two as separate. Okay, suppose you take S1 as sham. This is third style again. Okay, you ask, we did two now. as we
we
are
are
asking.
different as per customer
S2 equal
requirement.
to,
We
yeah,
need a
ST
mean.
equal.
Mm.
Okay, then you can just, so I'm
Then
not doing concatenation. See, definitely for concatenation, you should have a way of inserting space. You got it, Shyam?
hmm.
Without that, if you are asking something, it won't happen. You got it?
Yes.
So because we have to have that. Suppose if you just say that, okay, you can just say that, what is that? You can use, if the string is S1, okay, plus, you don't need that. And then again, second one is, what is that? S2, comma, what is that? You can add S1 and S2, I believe, comma. You can see that. So, yeah, I think I can remove that. I understand that, not a big issue. So there are other ways you can remove these two variables. You don't need to print them there. Okay. Now you can see that. This is a placeholder. Other way of using print statement. You got it, right?
So
Suppose
in
you want
hmm.
space. Space somehow you can manage here. Something like, I didn't concatenate here, even though, but this is not a concatenation, sham.
We are
So
providing a meaningful text to client. That is
that's
that.
all. Yeah, that's all. But for concatenation, suppose if you want to go with concatenation, even suppose if you are even printing, let me just show you this. So just added the string is. There are different ways. I'll just introduce all different types of printing strategies, maybe in the next class. Okay. The string
Sure.
is, you can just take comma, you can just take S1 plus. If you just do this, str of S2, again, it is same. Okay, I just need to close print. Okay, it will be same. So what is that you should do? Either the best approach is adding one more variable S2 equal to space and inserting between S1 and S2. That is the best practice. You got it?
Yes, sir.
And there is no other way.
Yeah.
You have to
Mentioned, in above you have mentioned F, then after within a string you have written something. Why we need to mention the F inside the print state?
okay. That is called format string. That is another way of adding this string formatting. You got it right? F in sense, it means you are adding a formatting string. You got it right?
Formatting. Yeah, okay.
But actually, if you can wait for some time, I'm going to discuss all these things.
Sure, sir.
You
Sure,
got
sir.
it right. You are little ahead of our what shall I say, our schedule.
No. Sorry,
Okay.
actually, most of the times printing statements we need to.
No, I'll
Uh,
I'll just see. I'll make sure that even what different prints because uh, we don't just use what we generally see in the most of the time outside. We use this kind of format strings when I work in development. You got automations. Understand, Sham? And I'll show
yes,
you there is one more style also. There are 3 or 4 printing styles. I'll just show you all that. Print is
sure.
same, but how you try to print it inside print is will change. And
Yeah.
I'm going to show you that. Got it, Sham?
Yes, sir.
It just allow me some time. Definitely, you will see all that. So only thing is just be patient, keep attending. Whatever knowledge you needed, you will gain all that in these sessions. I'm very sure. Got it?
Thank Yes, sir.
That's it. So I hope I answered most of your questions. What do you say, Sham?
Yes, sir.
Okay, right. Next, and anyone has any more questions till what we discussed in today's session or at least in last couple of sessions? Any questions? No? So then shall we jump to the next topic then? Operators. So what is that we have in operators? Right. You can see here. Operators is a very simple topic. I don't think it's too difficult to understand. Okay. So now These are different operators we have in Python. Arithmetic, you can see these are all arithmetic operators. Plus, minus, into, single slash, double slash, percentile, and this one is asterisk, asterisk, power or exponent. Okay, in the middle, this division, floor division, modulus, these are all doing division. Percentile gives you remainder, remaining looks for quotient. Understanding this difference is important when you start Python program. Especially someone who just starts Python, they need to get a clear idea on this. Okay, that's why I'll just show you some small examples, code snippets. These to understand difference between single slash, double slash, and percentile. But remaining operators are straightforward. You can see plus, minus, into, and this exponent, star, star. These are straightforward. We don't have any confusion there. But for beginners, there will be a confusion with this, especially not percentile, but single slash and double slash. Okay, let me just quickly test it. Okay, now I'll just show you here quick testing. So right. So now what I do is os.system. Let me clear it properly of CLS. Or we can directly go and run it from where? From Python. Let's test it here in this project. Suppose you have a equal to 10 and b equal to 5, friends. Now I'm just trying to work with the different scenarios. What is that? This is a Python comment, hash, single line comment. Okay, if you want to have single line comments in Python, you can use hash. Right here, what is that I am doing? Single slash, double slash, and percentile. Where I'm trying to explain you difference between these operators. Okay, you can see there. Now after this, I'm just trying. What is single slash here? You can see that it's a division operator, right? Which gives you quotient. Okay, and what kind of operation is performed when you say single slash? Generally, in other languages, we just only have slash. We don't have two different quotient operators. But Python provides that. If you are using single slash, we are doing floating point division or float division. What division? Float division. Suppose if you are using single slash, it also gives quotient, but the difference is it performs int division. Okay, and you know very well, int doesn't accept fractions, sir. Okay, whereas float accepts fractions. So slightly there will be a difference in the output. Even though both are working on quotient, right? Generating quotient. There is a slight difference between float and inference. You got it right. So we'll test it now. I'll prove that all that, right? That difference and everything, and make sure you understand it clearly. And this is reminder. So this is straightforward. We don't need to worry about this percentile. Percentile provides reminder or generates reminder. But remaining two, slash and double slash, has a slight difference between them. Let's test it. I have A10 and B5. Now what I'm doing here, I'm just applying single slash, right? So I just try to print off A slash B. Okay, what happens now? 10 divided by 5. This time we don't have big problem. We can see that the output is 2.0. Right? Similarly, I do one thing just to make it clear for you. I'll just say something like double slash, then just run this now. You can see that. This time you don't have a fraction because integer division is applied on the second statement. Here integer division is applied, here float is applied. But to see the difference, let's do one thing. Suppose I say print of B double slash A. What happens now? I'm trying to divide 5 with 10. Then what is the output? Let's run this now. Okay. Now you can see you got 0 for this operation. Actually, it should be, what is that? 0.2, right? It should be 0.2. If this operation is successful, you should see a quotient 0.2. But this is an integer division, right? So as it is integer division, it round off to 0. That's why you are seeing 0 here. Following? Right. Suppose do the same with what? With a single slash. Now you run it. Now you see you got, sorry, I told 0.2. Okay, it's 0.5. Okay, it's 0.5. Now you are getting a proper output here. This is the actual thing when you do a division, right? When you do a proper division, this is what the quotient is. But when you have to choose which operator you want to apply. Do you want to apply a float operator or you want to apply an int operation? That you should very clear. You understand now? So because one accepts what is that? Precision, and one doesn't accept that. So based on that, you should choose whether you should perform integer division for quotient or float division for quotient. If you are expecting full outcome, apply float division. If you want something, just want to round off there with some whole number, then choose this code division. I mean int division. But I hope I made you clear with this, right? Understood, friends? So this is difference between single slash and double slash. But in other languages, suppose you see like C, C++, Java, you don't have double slash, you just have only single slash. So just to make you understand that there is this difference in Python. Just observe that, friends. Okay, and percentile is simple. You don't need to worry much about percentile. You can just take print. You can just say A percentile B. Then automatically it just shows you. It gives reminder. Right? When you divide 5 with 2, so it divides properly, you get 0. Remainder is 0. If you reverse it, suppose B percentile A, whatever is remainder, it gives you that. That's all. So, and then run it. And you can see here it's 5 itself. Okay. So that's how you can quickly check on this division operators. And other things, plus, minus, into, and then that exponent operations, double asterisk. They are straightforward. Suppose as anyhow we are here, I just show you something like print A plus B gives you what? Addition. A minus gives you subtraction, and A into B gives you multiplication, or a product we can say. And there is one more. What is that? Print. This is not there in Java, all that. You do it with power function or something in those languages. And you can just say that A asterisk asterisk 2, which gives you A to the power of 2. What is the value of A? 10. So 10 square is nothing, but it should get 100. Okay, let's run this now. Now you can see that A plus B, 10 plus 5, 15. And then 10 minus 5, A minus B, I should put it as. Okay. 10 minus 5 is 5. And then 10 into 5, 50. And then 10 square 100. Like, right click and run this. You can see the output here. So this is how you can work on arithmetic operators. You got it right. So that's it, friends. I'm just only trying to show you. So you have all that here. I put everything here in the PPT. You can take that and test it. Okay. And also I'll share you some programs to practice and you can try that. Okay. Next after that is, I hope I made this arithmetic operators clear for all of you friends. Yes, sir. Okay. Next after that, comparison. Comparison means again, we use a lot of comparison operators or relational operators. Right? Everywhere you have a condition, then we need relational. And you cannot expect a condition without these operators. And always, when you apply these relational operators, always they produce true or false. The outcome is either true or false. And you can test all this. You can just quickly take this and you can test it now, either in prompt or either in, where is that? Let me just open PyCharm, right? So you can test all this here. I'm just, if you want, you can take one more for testing this. Right click new, Python file. So relational dot you can just name it as, just leave it like that. And just take two values, a equal to 10, b equal to 5. You can choose anything of your choice. In the next class, I will show you how to input from keyboard, different ways of doing prints. I'll show you all that because you are expecting on that as well. Okay. Before I jump to this control statements, I will also show you all that so that you can choose whichever kind of print you want. Sorry. So now you can just apply it directly. A greater than B, that gives something. By looking at values, you can easily tell that it is true. 10 greater than 5 is true. Okay. And then similarly, A less than B, 10 less than 5 definitely is false. Okay. And A greater than R. Okay. So next one, I'll just put a couple of things here. Okay. These are all very simple things to test. Okay. A greater than or equal to B, A less than or equal to B, and then A equal to B, A not equal to B. So these are all different relational operators we apply in our day-to-day development, right? So now what is the outcome? The first one is true, second one is false. By looking at that conditions, we can easily understand. We can easily predict that. Okay, A greater than or equal, 10 greater than or equal to 5, this is true. It is greater than, it's not equal. So less than or equal to B. So a 10 is not less than 5 or either equal to 5. So this is false. Okay. Next, A equal to B, definitely 5 and 10 are not equal. So that is false. A not equal to B. So then this is true because 10 not equal to 5 is true, or vice versa is true. Now you can run this. Now you can see that. So true, false, true, and then false, true. Just whatever we have just mentioned in the comments. So this is how you can use comments just to add your descriptions and all that. And in the beginning also you can use multi-line comment just to add that what is that about the program details, like who is the author and what is the kind of task you are doing, all that. I'll show you that even in tomorrow's session. Just how to add code hygiene and a bit of coding standards, how to add all that. I'll keep sharing all that time to time so that for a period you will be ready for whatever is needed for real development. Okay, this is the idea. Next one after this, we are done with comparison. Next, this is over. You can have examples here. I just added there. You can use that for practice. And logical operators and or and not. Okay, so what is this and here? Returns true if both are true. If two conditions are true, then it returns true. Else, if any condition is false, suppose you might and or concatenation operators. Both are concatenation operators. You can combine not just two, you can add many more and operations. And I do that regularly in my development. Excuse me. Because there are scenarios where while doing automations, I need to skip certain things from being part of automation. Then I have to see that if this is some path, or this is some path, or this is some path. So then all that should be skipped. That is the real usage. Okay. And you can combine not just two, you can combine 2 or 3 or 4. But for each condition, you have to use a separate and. And the syntax look like this. Even though the syntax is not there, I can just show you here. So what is that? The syntax look like some condition 1 and condition 2. It looks like this. And condition 3 and dot dot. You can add how many ever you want, friends. Okay. But now you can just ignore this if this is distracting you. Okay. This is the thing. So what is that you can do? You can combine multiple conditions with and. This, what is that? What operator is this? These are all logical operators. Understood? So it doesn't mean that you should just combine only two. You can combine multiple. Even same applies for R. Instead of this, just change this to or. Only difference is what? Difference is when you apply and every condition should be true. But if it is or, if at least one condition is true, it is enough for or. Difference is if you are applying and, it checks if each condition is true or not. And if all conditions are true, then your AND operation is true. But for or, it's not like that. Just if one condition is true and remaining all conditions are false or all are true also, still R is true. So that is the difference. Okay. And you can see the examples here. 5 greater than 3 and 2 greater than 2 less than 4. So both are true, right? Then AND is true. And in case of R, what is that? 5 greater than 3 or 2 greater than 4. You know, first condition is true, second is false. Still it is true because R just needs only one condition to be true. You got it right? So this is the idea. Maybe you can test it quickly here. Okay, let me just use this one. You can just try something like some 6 greater than 7 and okay, you can see here some 8 greater than 9. So this you can take this. What is happening here? 6 greater than 7 is false. If the first condition itself is false, then what's happening here is false. Suppose you say 7 greater than 6 and what is that? You can say 9 greater than some 5. Both are true, then you get true. And similarly, you can try R for R. You can take this, replace this with R, it gives true by default. Suppose you change this instead of 9, I give 3. You can see if condition 1 is true, but condition 2 is false, but still this gives true. When R is false, you can see this, some 6 greater than some 4, and both conditions is false in R. Only in such case, R is false. You can see, sorry, 6, this is, oh, sorry. Let me reframe it, 4 greater than 6. You can see that, false. Even if any one condition is true for R, that is enough to be true. When R is false, if each condition in that R is false, then only it is false. Okay, so this is a quick idea about what is that and R. And we use this a lot in our development, in our coming sessions. So you don't need to worry about it. And the last one for today is so not. What is that? So suppose true, not true. Okay, what is that? It is invalid syntax. Okay. It is for negation. Sorry, I think I applied in a wrong way. Not true. Also, not true. Not true means what it gives false. Generally, we apply it for a flip scenario. There are certain cases where I just, if there is something true, I want to flip that and change the outcome. In such cases, we apply this not symbol. Not means negation, opposite of something, this Boolean, right? That is not. So not true gives you false and not false gives you true. Okay, so likewise to flip scenario, we apply this not friends. So this is overall idea of what is that, which operators, logical operators. And you can also apply not like this on a condition directly, right? So, but in even that condition, it internally gets executed and converts to a Boolean. Any condition will be internally again is converted to Boolean. And then that on top of that, this not is applied. You got it right? Suppose I just want to show you one more last scenario, not 1 or not 0. You can see that. This is the final this thing actually. I'll talk more about it in upcoming sessions, but this is overall idea of what is that friends, logical operators. Overall idea of what is that, operators, arithmetic, relational and logical. We have few more friends that we'll discuss tomorrow. I'm not again going ahead of these things today. We'll do it tomorrow. That's all, friends. Any more questions? All right. If you have questions, I can answer your questions, else we'll take it up tomorrow. So that is the idea. Right. So is this clear? I hope probably you should get a clear picture about what is that about immutability, about that interning,